This is Algebra 1, Term 3, Lesson 9, Exponential Transformations. We'll begin in slides, then we'll move to a GeoGebra practice activity, and finally we'll go to Desmo's classroom to enjoy some marble slides. So let's start with our slides. The first thing students will do is graph two different exponential functions with the same base, both base 2, and then they will describe the transformation. So what did the plus 2 do? Now they will probably know a lot of this prior to this lesson because we have already transformed absolute value functions, and of course the transformations are the same. So here's another transformation. So again, they're just going to graph both and describe the transformation. Graph both. This is a vertical reflection. We'll use some of that language in class and talk about which, all the different ways to describe. The graph is inverted. The graph was reflected over the x-axis. The graph is upside down. That's informal, but kids say that. And then we'll put it all together. So here we have 3 different transformations. They should specify what each of those do. And here again, more than one transformation. When they get to slide number 7, they're doing something a little different. I want them to compare and contrast these two graphs. And the one thing I want them to focus on, and I will direct them there if I need to, is that the y-intercepts are the same for these two graphs. But if you go right 1, when x is equal to 1, those y coordinates are actually 2 and 3. So in our parent function, the base of our function, of our exponential function, is always going to be at that x equals 1 point, and I just wanted to point that out. They're going to see it when they do their GeoGebra practice, but I'm kind of pointing it out here so that they'll be looking for that when they get into those problems. Here's the first time I've mentioned the term growth or decay. I've said growth factor many times, but we haven't really talked about decay. So here I'm having them explain to me why they believe the words growth and decay are used for these two. So y equals 2 to the x is a growth, an exponential growth function, and y is equal to 1/2 to the x is a decay. And so we'll talk a little bit about that here. I will give them the information eventually that if that base is bigger than 1, we're going to say growth. And when that base is between 0 and 1, we say decay, of course. So let's move on to the last part of our slides, and that is our GeoGebra practice. Now I love this activity. It's a fantastic resource. Tim Brzezinski made this, and he makes so many good apps. This is one of my favorites. They are to graph exponential functions, and then I'm asking them very guided questions in their show notes, and I'll show you those. Okay, so when they get into GeoGebra, they're going to get a function like this one, and it's asking them to graph it. So they will do that by moving these numbers around. So this is 4 raised to the x minus 4 power and then plus 3. Well, they will actually move this over by grabbing this point at 0, 0 and moving it. So I need to go right 4 and up 3. All right, so basically I'm going to ask them questions about the red arrow, the blue arrow, and the green arrow. So what do you know? And they're going to use that in their explanations. So I'm asking them to describe the meaning of that number that has the blue arrow in their equation. So if we go into GeoGebra, that blue was actually the base, the 4 that's not in the exponent, but the 4, the base of the function itself. The minus 4 was the green arrow, it went right 4, and the plus 3 was the red arrow, it went up 3. So on the next slide, I'm asking about all 3, the blue arrow, the green, and the red. They don't all have green and red, so just whatever they have, they'll describe. And this really tells you a lot about how well they understand these transformations. It's not just an intuitive thing. And Here's just the green and red, and then finally put it all together again. The blue arrow, the red arrow, the green arrow. Where do you see those in your equation? So they're not just graphing them, but they're making sense of what the graph is representing. So this is a very thorough practice. The questions are important, so be sure to guide them to those show notes. Be sure they're answering these questions at the bottom. All right, our last activity is marble slides. And this is a classic. I did pare this down. This is technically an Algebra 2 activity, but I don't really know why, because transformations of exponentials is kind of an expected thing. In Algebra 1, we transform all kinds of functions, all the different types. All the parents of this course will get transformed. So I'm not sure why they thought it was Algebra 2. Probably because they had so many problems, and I just cut it down. I pared it down for you. This does have 18 slides, so this will take, at least half a class period. If your kids are really good at this, and they may be because they've already been transforming our absolute value function, so maybe they'll fly through here. We'll see, but this problem is not really a problem. They're just launching this to see what it does. And they're looking for the word success. So as soon as they see that word success, they move on to the next marble slides. Now, each of these is going to give them instructions, so guide them. Be sure they know they need to read that. It says change one number, so they should not add a whole bunch to this. If they mess up and change too much or make a mess of it, tell them to click on here and reset. And by the way, that is on screen 3. It directs them to click on the gear and then click on reset if they mess it up. So that does happen quite a bit, actually. So they're going to change 2 numbers in this one. Now this one has a restricted domain, so they're going to get a little bit of practice with that. This one has change 1 number. I am going to do a demo, but I won't show the equations because I don't want to ruin this activity for anyone else. So when you get the demo video, you can kind of see what it's supposed to look like to give you an idea. Now in this slide and in several slides, they're going to be talking about the numbers in the equation. What happens if we take that -3 and put a +3 there? And then here it says do it. Change the -3 to a +3 and tell me what happens. You may want to pace your kids on screen 7 so that they're not just looking at this and doing it and then coming back and answering it. We want them to actually predict prior to trying it. Of course, some of them are going to pull up that Desmos in a separate screen. I did give them a scientific calculator. I don't even know why I did because I'm not sure it would be of much use in this lesson, but this time, what happens if we change the -4 to a +4? Since they just practiced that, some of them will remember. And then this one, what if we change the 2 to a 1.2? Well, your growth factor is 2, so growth factor 1.2, what does that mean? And then here, they're going to do it. Change the 2 to a 1.2. And then here, what could your friend change to make this work? What do you suggest? And why are your changes a good strategy? Explain that. And then you're going to practice using your own advice on screen 14. And then here there's a challenge slide. They've already gotten you started on this one. But see, the problem with this one is these domains are not restricted, so it's not going to be able to get past this function. So most of them will do pretty well on that one. Now this one is blank, so they have to type their own exponentials, and they may need to limit the domain for each one. So just like there were a bunch of equations here, they may need a bunch of here. And I do tell them here exponential equation, so that should have something with an x in the exponent. This one says you can use more than one function type, so I'm giving them the liberty of using linear, absolute value, exponential. Those are the 3 we're comfortable with so far. But if they are crazy enough to try something they've never seen before, I wouldn't have a problem with that at this point. We're just kind of playing at this point. And then the last slide is free play. There are no stars, but can you build something that would be a challenge? And this would be something that would go well in a portfolio because it's something they built themselves. So they could put several exponentials on here. They may want to put some linear in there and some, but they need to have a way for marbles to get through there. So they don't want to just go absolutely nuts. They want to leave gaps for something to flow through. So remind them of that as they work on this one. It is supposed to be a marble slide, meaning there has to be a way for a marble to go from the top to the bottom. So that concludes our exponential transformations. We have one more lesson before our next test. If y'all have any questions or comments or need something that you're not seeing in these lessons, let me know. Y'all have a great day.